Good morning, everyone. Today we came here to see a little bit about JavaScript proxies. Hands up, who works with JavaScript or TypeScript? Okay, good. So most. I say like this title is a little bit boring, right? We are going to explore JavaScript proxies, but we are using them to build a time machine. And then also the title has to update. Let's build a time machine using JavaScript proxies. So it sounds a little bit more interesting from the beginning. So yeah, a little bit about me. My name is Marc. These are my social media handles. I'm usually active on X and also lately on Blue Sky. So if you want to follow me, I'm usually active on these platforms. Yeah, I'm from Luxembourg. I'm tech lead at Talk Event Software, which is a small software company in Germany. I don't work there full time, so I'm also an independent consultant. So if someone needs an extra set of eyes or hands on their projects, I can do that, especially if it's with Vue, Next, or TypeScript, JavaScript. That's the technologies I usually use and that I also love to use. I'm a student pilot. Why am I telling you this? Well, I try to bring it up as much as possible. All jokes aside, this is my hobby, which takes almost all of my free time. So when I'm not coding, I'm probably doing something like that, except when the weather is not so good. So yeah, this is how it looks like from the cockpit. This is from my last flight last month. This is how it looks like, my flight through Luxembourg, actually. All right, so let's get started on proxies. What are proxies? Let's take an example. So when you access the internet, it usually looks something like this. You make a request to a server somewhere on the internet, and you get a response back. But you can also put a proxy in between, a proxy server in between. Then it looks a little bit different. You send the request through the proxy. This proxy sends it to the internet. The internet sends it back to the proxy, and then the proxy sends it back to you. And this thing in the middle, the proxy, can do whatever it wants with these requests that you send it. It can cache it. It can even manipulate it. Whatever, technically, it can do whatever it wants. Caching is usually the use case. But yeah, we also have proxies in JavaScript, which looks a little bit something like this. And at the top, you see a regular object with two properties. And at the bottom, we create a proxy with this, of this object. And that's the line below. The second parameter there is so-called handler. In a second, we are going to see what it is used for. But when I do something like changing a value, like proxy.age equal 37, then the proxy sends this to a so-called target, which you can look at it as a state of the proxy, and then it's changed there. And the same if you access a property somewhere in your code, like in this console log, it also gets this from the target. But JavaScript proxies have like a superpower. It's like a little bit of magic that you can put in there. So you can actually customize what will happen if you set a value, for example. You can write custom code, and in a second we are going to see what this means. So you're not building on top of something. We can actually completely, or we have to actually completely erase the functionality and build it however we like. So if we want it to work as usual, we have to write some code. It's not just on top of it. The same magic goes for the getters. It's also when you get a value, you can do whatever you want with that value. All right, so we are going to talk a little bit about the time machine we are going to build today. A few words about this beforehand. This is mostly for fun. It's like we abuse the proxies a little bit for our own gain. We use them in a way they are probably not meant to be used, but we are going to do it anyways for the fun of it. And at the end, it's to get a little bit a glimpse of what proxies are, how they work, and maybe how you could use them in whatever way you'd like. There's a live coding demo where we go through different stages. At the end, we are going to have a pretty round time machine engine, if you want to look at it that way. And let's take a look what we are going to build. So in our first version, we are going to observe this, imagine a timeline, just a linear time, and there are these events. An event here is just a state change. So this is when something in our state, a variable, a property in our proxy changes. So age is 20, 21, 22, and so on. So imagine we have that, and then we are at some point in time representing the pink dot. And in this first version of our time travel, we can go backwards in time. So it's like an undo function, if you want, and we can go again forwards, which would be like a redo function, which is not really what a time travel is, but could be. But let's see, this is version 1. Version 2 is a little bit more like time travel. Imagine again, this is our timeline. There are states that we saved, and we are at the pink dot at the moment. And then we go back a certain amount of seconds back in time. And then what we do is we erase what happened afterwards. So we just actually travel back in time and not in steps. So that's the second version. And then the last version, which we probably are not going to implement because I don't know first if I have the time, and it's probably going to be a little bit too boring and a little bit too much. So if there's time left, we will see what we do. But here is what we are going to do in this third version. At the very least, we take a look at it and I explain what's happening. So we have, again, the timeline here. Let's call it timeline 0. We are somewhere there. Again, the pink dot represents where we are. And we travel again back an X amount of seconds or an X amount of time. But then we don't erase the future. We just create a new timeline. And we can create new timelines from any other timeline. We can jump into another timeline. We can go back in the past again there, and from there there's a new timeline spawned. And it looks something like this. So maybe it's not actually a time machine. Maybe it's something more of a multiverse. All right, so this, let me show you a little bit how more or less we want to do it on a big scale. So we will write a function. We call it create time machine, and we pass some data there. This data is going to be an object, something like this. And we get back a proxy. And what do we have in the proxy? We have like the target, like you remember the state or the state of this proxy, like the values that they have. You can already see we store multiple different things. They are probably not meant to be used like this, but we are going to use it like this anyways. So we have states there, an array of states. We have an array of timelines, and in which state are we and in which timeline are we. Then we override some setters to save the states, to manage some timelines, and also we override getters to represent the regular behavior of our object or of our proxy, and to add some extra functionality for our time machine. With all of this, we also get free reactivity. So this is one of the first things we do. We add free reactivity because why? This talk is actually generated from an idea of another talk I gave, which was recreating the Vue.js version 3 reactivity from scratch, and this is made in a proxy. So we just added on the fly some rudimentary reactivity with our time machine while we add it. All right, so some coding time. Let's get into it. Can everyone see in the back the code? Probably not. Can everyone see it like that in the back? Yes? Okay, perfect. And this one here, maybe I can zoom in this a little bit. The top is not important for this one. We are going to look at the beginning only at the console. So it starts out with some examples in the console. Then we have like a little demo project, and at the end we have like a 2D role-playing game like that I coded up for this talk. And then there we add our time machine and we add some more functionality. So it's a little bit step by step. Might look a little bit boring at the beginning, but it will get more exciting the more we progress. So stay tuned. Just let me see the time. Do we have the time somewhere that I have left? No. It's okay. Okay, so this is actually not what I wanted. Start. Okay. So here we just have a HTML file and a file proxy.js. Nothing happens, there's just a console log. So let's just start with, we create an object, let's call it product, and we have a price of €6 and a quantity of €2, of 2. Then, now we go ahead, we log out the property, so the price, for example, and then we go ahead, we change the price, and then we log out the price again. And it does not work. Okay, yeah, it does work. Okay, so you see, this is how a regular object behaves. We all know this. Okay, let's now create a proxy. In your proxy, we pass the product here, and then we have a so-called handler here. In a second, we will see what it is. But for now, let's just leave it like this, and we replace product with proxy here, and it still works as should. It gets the data, it sets the data, it gets the data again, it changes, everything fine. Great, so now we have this handler here, and there we can override stuff. So if I overwrite the getter, which would look something like this, then we can already see we have an issue. So it's undefined because, well, we're not returning anything. I told you we don't build on top of the regular behavior. We have to replicate it if you wanted to do what it should do. So here we already have to do something. So this getter, it has a few parameters, a few arguments. So it has target and property. And here, let's log out the target first to see what it is. Nothing special. It's just, as I told you, the original or the state that is currently it. So here we change the price to 1,000, and then you see the target, which is, I imagine it as like an object that lives within the proxy that gets changed. And let's say get the property. And this is just the name of the property. Here, in this case, it's price. If we want to get the quantity, it says get quantity. So all we have to do, so if we return something here, for example, 0, we can see it returns 0. So this is where we have to do something, and we can just return target at the property of whatever property it is that we are passing. And we have our regular functionality back. Great. So let's move along and go with the setter. So what would happen? Here we set the price. if our setter isn't implemented, what happens? It just doesn't update because nothing happens in here. So here we also have the arguments, a target property, but also a value. So the target, we already know what it is, but we can log out the property and the value. Prop and value. And it's like, you see, set price to 1,000. Cool, so what do we do? Well, like it's regular object manipulation. So target at property equals value. We don't have to return something. The return value is to see if to indicate if the change has been successful. We just assume here the change has been successful. We don't have to return. We could return true, but this should work. So now we have our regular functionality back. Great, so we already did some work just so it works as before. Let's refactor this a little bit. Let's call it create time machine with some data. It's not a time machine yet, but it will be, so I just called it create time machine. We refactored this a little bit. We can return immediately the proxy, and we pass in as initial data the data that's passed to the function. And that should be good to go. We can apply this, for example, to our product here. And we can rename this again as product. And now we can use product as before, just that now we have special behavior. In this case, the special behavior is just logging stuff out. But it becomes a little bit more interesting in a second. So this was the first little demo. The next one, let me close this. The next one is also a small demo. So let's just copy our function here, paste it in here. So that's good. I will show you the HTML file in a second. Okay, now I might have to zoom in a little bit. Okay, so this is probably not very inventive, but I couldn't come up with a better example for demonstrating this. So we have a name, and age, and health. And so we can increment the age with the age, the health decreases, then maybe you go to the doctor, the health increases, and so on. So that's like the time travel thing that I want to use to show what's happening. So here we just have our state, which is person. Then we have a bunch of stuff just to update our DOM. And then we have a few functions here: decrease age, increase age, set health, and then we have forward and backwards for the time machine functionality. But we can see already that we have display state, display state, display state. So this is already not perfect. And this is where I told you we will have free reactivity, and this is where it comes into play. So let's just plug this into our time machine. Create time. Did I not? It should autocomplete. Okay, it works anyways. Okay. So yeah, you can see we already have a bunch of outputs. Just missing one. No. Oh yeah, so you can see we have here set age if we increment, and then we have a bunch of get, because that's how the code is written. We get the name, we get the age, we get the health, and so on. Okay, so let's say here the display state is repetitive. We don't want this. Let's just remove it, except the last one because it's the initializer. So now when we change, nothing happens, right? It just changes here, and when we set it, yeah, it changes, but it's not displayed because we don't have the reactivity in there. So what we can do in our time machine function here, let's just accept an argument on update, which is going to be a function. Let's default this to a function that doesn't do anything, just in case there's no function passed. And then when we set a value, we can just call this, and then it will call whatever function we pass. In this case, we already had a function here, display state, that does all of the DOM rendering of all the values. Not very performant. In Vue.js and React as well, it's all more optimized. I'm not even sure if in React this is the case, but here we update the entire DOM, whatever happens. So it's good enough for our little example here. So let's try it again. So again, we have the time machine, we pass our function here, and our proxy takes the function, executes it when we set a value. So let's go ahead and set a value. That already works. So we already have our free reactivity that I promised you. We have it built in. Nice. So also the name change works. Okay, so we still don't have any functionality of the time machine, so let's get into that now. How would we go about that? Let me see. I think I have a slide about this. I'm not even. No. That's okay. Not a problem. So here we pass the target, and I told you we are going to misuse this a little bit. So instead of just an object, we create our own object, and it's not going to be the data. It's going to be states. It's going to be an array, and then we have something like a current index of zeros, just to show us at which point in the array we are located at the moment. Then maybe as an initial state, we pass the data here. And then we can already see states here, but a bunch of stuff doesn't work. So we have undefined nan, and this is because, yeah, we don't have the property of target anymore. The target is very different from what it was before. Now it's one of the states, in this case, the first one. So let's just go ahead and write our current state. And what would this be? So we want something from our target. We want the states. So target states. And which one? Well, we also have target current index. So target current index. And then instead of the target that we had before, this is actually our new target. I could also call it current target, now that I think of it, but it's okay. So current state. So we can already see the values are back, but yeah, obviously our setters are not really working. So this is the next thing that we have to do. How would we go about that? So we have an array, we just push the data in there. So we can go ahead again with target states, and then we just push. And what do we want to push? Well, let's just say we spread our current state. Actually, we don't have the current state here. Let's just copy this down. The current state, and then we want just to override the property that's going to be changed. So we want something, if the price changes, the price to be value. And the syntax to do this is just a little bit counterintuitive, if you ask me, but this is how it works. By the way, I don't know if I mentioned it, all the code is on GitHub. I will have a QR code for you later if you want to take a look at this at home with a little bit more focus, so no need to write too much of the code down or anything. So yeah, so we have the current state that we have, but we just override the property with the value that we are getting here. And one more thing that we have to do, we have to update our current index. If not, it just stays there. So let's see. Our value here changes again. Nice. The only thing that doesn't work is our display here of the object, let's say. So this is again because we were accessing here just person. So in this case, just person isn't what we expect. So let's just say we want person.current state. It still doesn't work because there is no current state on our proxy, but we can do whatever we want in the get. So we can just do if our property, is current state. Then, yeah, we just return the current state. So this works. Should work, yeah. This works. The health indicator works as well. And the name change also works. OK, so this is the, I don't know if it's quick and dirty. I don't know if it's meant to be used like this, but it works pretty well. So I think the proxies are meant to just do whatever you need to whenever you change or get something from your proxy. You can, you could send an API request to log all the changes in your variables that are changed. Like, you can do whatever you want in there. So this is what I choose to do. I just check if it's current state. It does this. Cool. We still don't have reactivity. So let's get to it. We have here forward and backward. It should probably be forwards and backwards, but let's just stick with this now. So this is a function, right? But it's also a getter. We are getting something, just person dot something. We are retrieving it. So we can do something like, if the property is, what did I say, backward? Well, we have to return a function because it expects a function because it executes it. So let's just return then a function. And what do we do with the function? Well, we just update our current index to minus minus, and we don't have to forget to update our DOM. So let's just see if this works. Let's just get h+++, and then we go backwards, and then it goes backwards. Cool. We can do the same thing with forwards and just index ++. So let's change again. Here, just go up in the h, so we can go backwards, forwards. So this works. We can change the name. Huh. Oh yeah, OK. This is an issue. It looks weird, but it probably makes more sense when I show it to you in the 3D game, in the 2D game in a second. So yeah, small issue there, but the rest works. We can go backwards and forwards in our timeline. So this is the version 1 that I showed you. This is what we have now. OK, so in version 2, we are going to jump back in time a certain amount of seconds. So here it's not really visual how you can do that. So I created a small game here. I know the graphics are not very fancy, but this is it. Let me just make it bigger for. So I have like small wizard there that can move through the maze, and there are things happening. So there's a snake. What do you think happens when I go to the snake? Well, it might bite me. Yeah, it bit me. Health decreased. I was bitten by the snake. OK. But there are also potions. When I take a potion, hey, health is back to 100%. Nothing happened. Let's go along. So the rest should be a piece of cake. So we just go there. What's that? Flames, minus 50%. What happened? Let's go to the console. An invisible hazard. Health decreased to 50%. Not good. So we go ahead. So now it would be good if we could go back in time just to make sure that we don't step into fire. So, but yeah, we went there, and then, oh my God, another invisible hazard, minus 50%. We are at 0. We lost the game. OK, so here I want to implement a little bit of time machine. So let's zoom it in a little bit. OK, should be good enough to see. OK, so I open the game a little bit. The game and also the time machine. So this we don't need it anymore. This we do need it. It's our time machine that we have as for now. I just copied this in the file that's called time machine. So we can close this. We have an HTML file that has like almost everything you can see except a few hidden buttons that I will activate actually now, so we can see. So that we can go backwards, forwards, and back in time. Okay, and the rest, yeah, previous timeline, next timeline, we come to that in the third step. But for now, it's just this. Yeah, we have a map, we can manipulate. This is like the map editor. We could, if we change this, you can see that there's more trees added, and I just leave it as is. So this is just a map, and then we have our game file here. So the HTML, we actually, I think we don't need it anymore. And then the game, let me just work through it very quickly. There's nothing special. It's also not really sure if it's well written. It's for purposes of demonstrating the time machine. So we have what means a hazard, how to represent it basically, how to map the map to a matrix so we can use it. It's a two-dimensional array. And then we have the state. This is where it becomes interesting. This state we want obviously to be first reactive. Second, we want it to be time machinable. Is that a word? Well, now it is. We have print game, which renders the entire thing. Yeah, the player, print the stats, and then we move the player. What happens here? We read a bunch of states, and then we also write a bunch of states. Here we write the health, we write the health again, and then we write positions. We have some event handlers for the arrow keys, and then we have our functionalities for that just passes stuff to the proxy for our time machine. Okay, let's go ahead and just plug our time machine here, just to see what happens. Let's open the log, and we can see already a bunch of stuff happens that didn't happen before. The get is probably a little bit too much, because every time we move, there's a bunch of stuff being read, so we can render it in the DOM. So I think the getter I will just comment out for now, so we can look at the state changes here. So we can already see one small issue. I think it's better when I just log out the states here. So every time when we move, there are two states added, even though we just move into one direction. So we can already improve a little bit upon our time machine here, because when we move somewhere, it just assigns the X and the Y coordinates. It doesn't matter if it's the same, but we can just say if the current state property is already the value, I just return from there and don't go any further. And we already improved. Now it's just one state change at a time. Okay, so can we also go back in the steps? No. Here it's backwards with an S. Okay. You would have thought that I would have figured this out. Forwards and backwards. Let's see. We can go back in time, forwards in time. And now I will show you what happened before. So now I went back in time. I moved somewhere. And oh, I wanted to move down, and now I wanted to move left. It goes whatever, it looks weird. And then I go up, and then it jumps somewhere in the screen. So it doesn't make sense. But let me explain you why. So we have the problem that when we go steps back in time, and then we add a new state, this is what happens. We have the current index, like these are the states, right? And then we just go back, reassign the index to another index, and then we add another state here in pink. And then when we want to add a new state, well, the index, it just jumps to the next state that was already saved. So this is a small error, like logical error here. So what we really want to do is we have our index there, it jumps back, and then when we do a new step, when we add a new state, what do we do with the history, or in this case, the future a little bit tricky, but yeah. I think you can look at it however you want, because the time travel doesn't really exist as far as we know. But I would just say we delete it, because if not, it's impossible to have all of this, except with the timelines. That's it in the third step. This is where we would create a new timeline, and then from there on we do the next steps. So we would just erase everything before, we add it, and then we erase the rest. Just quick confirmation, I still have 13 minutes, is that correct? Yes, 13 minutes, okay. We should be fine. Okay, so let's fix this. We can fix it by probably, how was it? So our states, let's just reassign the states. Yep. And we slice them from 0 to our current index. I would like to say current index plus 1. If not, it forgets 1. Let's just see if it works. So we go ahead, we move a little bit, we move back, and then we do a new step, and now it works correctly. And if it overrode where we went on top, now it just where it went on the bottom. So this works. Good. Then there's another issue that we haven't thought, or we haven't even talked about yet, and it doesn't have anything to do with time travel. It has to do with some particularity of JavaScript. So if we go here, we take this potion, it disappears, correct. We go back a few steps, it doesn't reappear. What happened? Let's take a look at our states here. So we have the health, we have the positions, and we have the matrix. Well, the matrix is an array, is actually an array of arrays. So what does this mean? Someone know what's happening? Yes, I'm mutating the matrix because it's called by reference, not by value. So we have our current state here. If we push it, this is our current state. We have the position, we have the health, and we have our matrix. Everything is fine. But then when we add a new state, everything is fine except the matrix. This is not a separate object. This just refers to probably the first, not object, the first array we had. So once we change it, it changes for all the other states, which we don't want to. So we need to duplicate this. You can already see there's issues here of performance if you do this at large scale, because we have a lot of states with a lot of copies, but for our small game, it should be fine. So let's fix this. This is a quick fix, actually. We have since March 2022, I looked it up, we have structured clone. We just structured clone, and then it's like a deep copy of the entire object or array. So here at the initial initialization, and here when we add it, also structured clone. Let's try again. Oops. We take the potion, we go back, and it puts the potion back, because now it's an actual separate object. Cool. Now we want to travel actually back in time. Let's go one last time to the slides to see how we are going to do this. So first, how do we even know where to jump back to? So we need something like this, a timestamp. So we just take this timestamp, we smash it on all the state changes we have, and then we go ahead and we say, we look for, if it's this much time in the past, we just cut it off. We just delete it. Well, we just move the index and then we delete it. So that's what we are going to do with just jumping back in time instead of jumping back in steps. So let's do this. This is the last thing that we code. The rest is just show and tell. So let's see. Let's go one last time in this file. We have back in time. It's again a function, and the function accepts seconds, which is a number. So let's go ahead and do this. So we have here, if it's forwards. So here, if it's back in time. Did I delete one too many? Okay. So we return a function. Okay, what do we do here? So first, I said we slap a timestamp on all of it. So here, let's just go ahead. Timestamp, new date. Copy that, and then also here in the bottom. Oh, didn't copy, okay. New date. Okay. If we move here, we can see in our state that we have that timestamp. Cool. Now we can go ahead in our back to time function. We can get our target time, which is when we want to do the cutoff. Could be cutoff time as well. I call it target time, which is, I think this. This should work. So date minus seconds. If there's probably an easier way to calculate the difference in seconds between two timestamps, but this is, yeah, this is it. Say again? This should work, right? So our current timestamp minus x seconds. Then we want to find the cutoff index. So we get this from our states. We find the index where the state, the timestamp is older than the target time. And then from there we delete it until this one. So we do the same as we did before. So target states, and then we slice it from 0 to the index. We also update the current index. And we call the onUpdate method. Okay. So this should work. Let's see. There you go. We jump back in time 5 seconds. Yeah. Say again? Oh, yes. Thank you. Let's try again. Might be index plus 1. Let me just see. Okay, good. So if we are here now, let's say here, we wait a few seconds. 1, 2, 3, 4, 5. We go through the fire. We go back 5 seconds, then we are again back where I think we're actually not going back enough, but it's okay. Basically this. So yeah, we have our basic time machine. I see I have just 5 minutes left, so I want to show you the end results with all the timelines and everything. So here I do a hard reset, delete all our effort, and then we also do a time jump to when everything is finished. So this is the game. So you can see the wizard here. We go. Then we go back in time, 5 seconds. And then it went back in time, but I can switch the timeline. And I'm back where I used to be. I can work from there, or I can change the timeline again. I can go from here. I can go back in time again. It creates another timeline, which then I can go to, and then I can do this infinitely. So we even have a timer here. I actually wanted to invite someone up to come and play, but I think we don't have enough time. I want to explain very shortly what happened here. Nothing too fancy. Basically what I did is I added instead, or I added a new layer on top of the state. So we have just timelines, and everything that used to be target states is now target timelines, current timeline, states, current index, something like that. So a large thing like this could probably also be programmed a little bit easier, but it's basically we have an additional array with all the states. So you can see it's not the perfect solution probably, but it works. I didn't want this. So yeah, so this is homework, not for you guys, it's for me, to be lighter on the memory. So what could we do? Instead of saving the entire state, we can just save the change and then roll back the changes. That would be more memory efficient. I really wanted to have interaction with the past player, but that would have been a little bit, I got it sort of working, but it would have been crazy to explain. And some grouped transaction. If you see, we move to a space, and then we change the position, and then we change the health, and then we also change the matrix. Those are 3 states we change, and it's actually just one transaction that we want to do. So this is also homework that could be done to make this a little bit more fun and more well-rounded. But this is, yeah, to explain a little bit how proxies work, you can go to the website there, marcdev/time machine, or scan the QR code. It goes to GitHub. All the code is there, so you can take a look at it in your time. And yes, thanks a lot for attending, and I hope you had a lot of fun. We have 2 minutes. Any question? Many. Yes.
How would you go about improving the memory usage in your program? Besides the structured clone, I don't know if that would work well in a big scale.
Yeah, about the matrix, not sure. We could do something like just saving which part of the matrix changed. So we save the x and y coordinate in of the matrix, and which one changed. But there we would have to be very specific. So we would have to be, if it's matrix, then do this. But we could just, instead of changing the entire matrix, just what changed, like the coordinates and the new value. That could be thinkable. Okay. Cool. Thank you.
This is our moment.